Over the last 30 years, artists and designers have completely redefined our relationship with space. The environment is no longer a passive backdrop. It has become a living, active entity, what we call an interactive ecosystem or habitat throughout this course. In this lesson, we will immerse ourselves in this concept through a selection of highly significant case studies. For each one, I will ask you to pause this video, watch the artwork in action, and then we will share a few thoughts about it together. Let's begin with an absolute milestone from 1967, Spazio Elastico by the Italian artist Gianni Colombo. Please pause the lesson now, watch the video shown on screen, and come right back. In this work, you experienced an immaterial shifting environment. Colombo used elastic cords and stroboscopic lights to shatter our normal spatial references. This piece is fundamental because it marks a historical shift. Space is no longer static, it becomes a responsive variable completely dependent on the observer's movement. Now let's see what happens when digital technology enters the physical space to create a sensitive habitat. I want you to look at Tavoli, created by Studio Azzurro in 1995. Please pause the video and take a look. As you saw, touching the tables brings the projected static figures to life. This work is crucial because the technology is sophisticated yet completely invisible. The interaction is not driven by complex controllers, but by everyday, instinctive human gestures. It perfectly defines what a sensitive environment is. Let's push this further. Can an interactive ecosystem merge with a biological one? I have two examples for you. Interactive Plant Growing from 1993 and Dune from 2007. Please pause the lesson and watch both videos provided. In the first video, you saw that touching real living plants triggers bioelectrical signals that drive the growth of a virtual forest. In the second, a public path of fiber optics reacts to human presence and sound. We observed that our physical and emotional state can directly shape the digital and physical landscape, creating a true hybrid ecosystem. Now let's look at how we can spatialize invisible data within an environment. We will look at Voice Tunnel by Rafael Lozano-Hemmer and Raw by the collective Tundra. Pause the lesson and watch these two immersive installations. What you just observed is relational architecture in action. In Voice Tunnel, the invisible sound of human voices is given a physical body through dynamic light propagation through the space. In Raw, abstract digital data is translated into floating visual symbols using holographic LED fans. These works are important because they make the invisible data flow of our modern habitats suddenly tangible and visible. Finally, let's look at a large-scale, fully realized interactive ecosystem. Watch the video Connected Worlds by Design.io, created in 2016. Pause and come back for our final analysis. You just saw an immersive environment where children use physical wooden logs to divert digital water flows. This work is a masterclass in interaction design because it simulates a complete self-sustaining ecological system. It teaches sustainability not through screens but through embodied spatial cooperation within a digital habitat. All these case studies show us that behind every interactive ecosystem there is a hidden architecture. We no longer interact directly with the environment, but rather with an intermediate computational layer that sends us and reacts. In the next lesson, we will uncover the theoretical framework behind this process. In the previous lesson, we explored how artists augment space through multimedia installations. These experiences demonstrate that the relationship between humans and their environment is no longer a direct, purely physical interaction. In contemporary design, our perception and action are mediated by a technological system, a machine that acts as a computational intermediate level. This system transforms the world into an adaptive and responsive habitat, where the machine senses us, processes our data, and generates dynamic responses. To design such complex system, we must deconstruct the interactive ecosystem into three functional layers: the input layer, the computational layer, and the actuation layer. Think of this as the nervous system, the brain, and the muscles of your habitat. This architecture allows the machine to create a bridge between the human experience and the digital realm. Throughout this course, we will use VVVV-gamma to program exactly how these layers talk to each other. Let's analyze the first point of contact, the input layer or perception level. Here, the systems gather sensory and biometric data from both the users and the surroundings. In this framework, the user is far from being a passive observer, like a spectator in a traditional cinema. On the contrary, the user is the primary stimulus, the very engine that triggers the artwork. We are looking at a cybernetic feedback loop. The human stimulates the system through an interface and is in turn stimulated by the system's sensory response. A crucial step in professional design is defining the degree of expertise of our users. We generally distinguish between two profiles. The visitor or spectator is a non-expert who interacts without prior instruction. For them, the interface must possess a clear affordance. It must be intuitive, making discovery part of the artistic process. Conversely, the actor or performer is an expert user. They know the rules and use the system as a precise, expressive, or musical instrument, like a dancer wearing sensors or a musician with a custom controller. Finally, we must consider how the action takes place, moving from explicit to implicit levels. This leads us to the paradigm of embodied interaction as defined by Paul Durisch. Explicit action is voluntary, a gesture, a voice command, or touching a tangible object. But the new frontier is implicit action. The system reacts to your simple presence tracked via computer vision or to your biometrical data like heart rate or brain waves. In this scenario, the user interacts with the habitat simply by being there. Once the system has perceived the user through the input layer, we move into the computational layer. This is the brain of our habitat, the calculation system where raw data is filtered, analyzed, and transformed into a coherent response. Here, the machine operates as a bridge, managing complex environmental simulation and real-time interaction logic. In a professional setup, this is exactly where VVVV-gamma shines, allowing us to manage high-level algorithms and data flows simultaneously. The final stage of this cybernetic cycle is the actuation layer, also known as the level of representation. This is where computational decisions are translated back into sensory experiences. In this context, we use the term medium to describe the physical means through which we manifest the system's reaction. Whether it is a laser projector, a multi-channel audio system, or a kinetic robotic structure, this layer is responsible for closing the loop and stimulating the user's perception once again. But how do we bridge the gap between these two worlds? This is where the interface comes into play. It is the contact point, the interactive membrane between the human and the machine. The interface qualifies the relationship. It allows the human to communicate actions to the digital world and conversely allows the digital habitat to respond. It is never a neutral tool. It is a space of relationship and mutual understanding. To design effectively, we must distinguish between two main interaction paradigms. The primary interaction paradigm is what we are most familiar with: mouse, keyboard, and touch screens. These are based on direct, conscious, and often static input-output models. While still dominant, they often limit the complexity of our bodies to a bidimensional interaction. The secondary interaction paradigm, however, pushes the boundaries into the interaction habitat we are exploring. Here, the machine becomes adaptive and often invisible. Input is no longer just a click. It expands into voice UI, body movement, or even biotracking. Similarly, the output evolves into a spatial, audio, haptic feedback or kinetic systems. In this paradigm, the interaction becomes poetic, aware, and deeply integrated into our physical reality. To understand where we are going, we must look at how the definition of the interface has evolved. As early as 1962, Marshall McLuhan described the interface not as a tool, but as an extension of the skin. Later, Steve Dixon simplified this by stating that interface means interaction. This means that the interface is not a neutral box. It is the very space where the user manipulates information in real time. It is the boundary that defines the quality of the experience. As Brenda Laurel points out, the concept has moved from simple hardware and software to include the cognitive and emotional aspects of user experience. Our sensory perception is heavily filtered by the interface. It serves as a probe for understanding the world. To see a radical example of this, please pause the lesson now and watch the video for Blind Smell Touch by Peter Decouper. Observe how he redefines our relationship with our own senses. As we have seen from that experience, in the world of interactive media art, we have moved past the traditional paradigm of the mouse and keyboard. We now explore what Katja Kostek calls interactive object art. We can categorize this into three main types: tangible interfaces, physical objects equipped with sensors that we can manipulate like interactive sculptures. Intangible interface, interaction based on space and body without physical touch using voice UI, gesture tracking, or computer vision. And finally, the new frontier, wearable and bio interfaces. These are technologies that read the body directly, tracking heart rate, body heat, or even brain waves through neurofeedback systems. Some tangible interfaces are even called reactable interfaces when the medium of representation is contained within the object itself. A fascinating example of this is Klans Klanke project. Please pause the lesson one last time to watch this physical-digital hybrid. We have seen how space transforms into a habitat through a computational layer and how our bodies become the primary triggers for these ecosystems. From now on, we will stop talking about theory and start building. In the next module, we will open 4V Gamma for the first time to begin constructing the computational layer of your own interactive habitats.